Now, we spent a lot of time on this state here, and I showed a lot of alternatives, but up to this point, of course, we're not doing too much with that state. That's what I want to change now, though. Now, I want to make sure that this form can be submitted when this button is pressed, and that then we basically gather these different state slices here and combine them into one object, which for the moment is then just logged to the console, but which we can use for different things later. And therefore, we want to listen to the form being submitted. Now, we could add a click listener here to this add expense button, but this would not be the best way of listening here. Because indeed, there is a default behavior built into the browser and built into forms on web pages. If a button, especially with type submit, is pressed inside of a form, this overall form element will emit an event to which we can listen. And that's the submit event. So it's on this form where I want to react to on submit and then execute some function whenever this form is being submitted. Now that's a function I'll add here, and I'll name it submit handler, like this. And then here we just point at submit handler as we did it for all the other events as well. Now the thing here is that I just said that this is a default browser behavior, and unfortunately a part of this default browser behavior is that if you do click this button, the page reloads, because the browser actually automatically sends a request whenever a form is submitted to the server which is hosting this web page. So in this case, to this development server. And that's not what we want here. Instead here, we want to handle this form submission with JavaScript and manually collect and combine the data and do something with it. Thankfully, we can disable or prevent this default behavior, because we again get an event object here automatically, just as for the change events. And on this object, we can call a prevent default method. This is built into JavaScript, nothing React specific. This is default JavaScript behavior. We can prevent the default of this request being sent. And since that request is not sent, the page will now also not reload, because we stay on the currently loaded page without sending any request anywhere, and we can continue handling this with JavaScript. So therefore now we can create our, let's say, expense data object here, and now combine all that entered data. Of course, if you used this one state instead of three states approach, you already have such a combined object. But I don't have that here, so I will now create it once the form is submitted, and simply add a title here, and set this to the value stored in the entered title state, add an amount property, and set this to entered amount, and a date property, and actually set this to a new date, constructing a new date with the built-in date constructor, to which then in turn I pass the entered date, which will parse that date string and convert it into a date object. Now these property names here, title, amount, and date, are up to you because this is your object. This here, of course, entered title, entered amount, and entered date, points at these state variables, so to say. If you used the combined approach, you also might want to remap the property names, because later in the app I will rely on having a title, amount, and date property name. So make sure that these property names exist and hold the correct value. And then for the moment I will just console log expense data, so that we can see that. Now if we reload this and enter test and 12.99, and then pick some date here, if I click add expense, that's looking good. We got this object which has all that data stored. So this now also works, and we are reacting to the form submission. Now I also want to clear the inputs to delete the entered values when that form is submitted. How can we clear those inputs? Well, That's part of the reason why I wanted to use state for storing the entered values. We could have also used the global variables outside of the component function otherwise, if we just wanted to persist the values, but by using state we have an advantage. We can now implement something which is called two-way binding, which simply means that for inputs, we don't just listen to changes, but we can also pass a new value back into the input so that we can reset or change the input programmatically. And how do we do that? Well, it's very simple. All we have to do is add the value attribute, which is a default attribute, to this input element. This will set the internal value property, which every input element has, and we can set it to a new value. And here I will bind this to entered title. So now this is two-way binding because now we don't just listen to changes in the input to update our state, but we also feed the state back into the input so that when we change the state, we also change the input. This might sound like an infinite loop, but it actually isn't, so we won't have a problem there. But the advantage is that when the form is submitted, for example, we can call setEnteredTitle and set this back to an empty string, which also was our initial state. And by doing that, we override what the user entered after the form was submitted and therefore clear the input. And we can do this for all inputs. We can set the entered amount to an empty string and set the entered date to an empty string, and then just add the value prop to all these inputs. So here I add value and point at entered amount to pass that back into the amount input, and do the same here for the date. Pass the entered date back into the input. If we now save that and I reload, this is looking good. Now we can still enter something here as it seems, but if I click add expense, you see it's all cleared again. And we still have our data collected and stored here in this object. So this is a neat behavior, but more importantly, this is also another key concept in React. Two-way binding is very useful when you're working with forms, because it allows you to gather user input, but then also change it, for example, upon form submission. Now, with the changes we made over the last lectures, we are able to gather our expense data, our user input, and combine it into this object and clear the form thereafter. The only problem is that having this data is nice, but we technically don't need it in the expense form component, do we? Instead, we need it in the new expense, or to be precise, in the app.js component even, because there we have our expenses array, and ultimately our goal will be to add this new expense which the user entered to this list of existing expenses. And we probably also want to enrich it by adding an ID. So we need to pass the data which we're collecting and generating in expense form to the app component. Now, up to this point, we only learned how we can pass data down. So how we can, for example, in the expenses folder, pass the title, amount, and date from the expenses component to the expense items component. So from parent to child. That's something we learned. We can do that with props. But how can we do it in the other direction if data is generated in the expense form and we then want to pass it up to the app component? Well, actually, we already saw how it works, but it's easy to miss it. So let me show it to you again. In expense form, we are listening to user input, to changes to the title input, for example. And whenever the user types there, this function, title change handler, executes, and there we get this default event object. That's something the browser gives us. Now, actually, we can think about this input element here as a component as well. It's not one of our components, but it is simply a pre-built component, we could say, provided to us by React and of course translated to the input DOM element. But it has this component character in the end. And we do also set some props on that component, including this special onChange prop. Now actually, this onChange prop isn't that special. It's just a prop named onChange, which wants a function as a value. And then internally, the input element adds this event listener. So React basically sees that we set a value on this onChange prop and adds that listener on the rendered input element. But that is a pattern we can replicate for our own components as well. We can create our own event props, if we want to call it like this, and we can expect functions as values, and that would allow us to pass a function from a parent component to a child component, and then call that function inside of the child component. And when we then call a function, we can of course pass data to that function as a parameter. And that's how we can communicate up from child to parent. Now, in case this was too quick, let me simply show it to you. Let's say we want to pass the expense data, which we gather in the expense form component, to the new expense component as a first step. Because if we ultimately want to reach the app component, we first of all have to reach the new expense component, because it's the new expense component which uses the expense form. And then in a second step later, it's the app component which uses the new expense component. But we can't skip components in between. That's also something you learned in the previous course section. Props can only be passed from parent to child. We can't skip intermediate components. So therefore, as a first step, let's make sure we can pass the expense data to new expense. And we can do this by adding a new prop to expense form. It's our component, so we can name it however we want, but I will name it on save expense data. But the name is totally up to you. I'm just naming it on something because I want to make it clear that the value for this prop should be a function which will eventually be triggered when something happens inside of this component. In this case, when the user saves the entered expense data, so when the form is submitted in the end. So that's again a convention I'm following. You don't have to name it like this. You can name it however you want. It's totally up to you. It doesn't have to start with on. I just do start with on to follow this convention and to make it clear that the value for this prop should be a function which can then be called inside of the expense form component. Hence, it's a function we should define here in new expense, just as we did it for the input elements with the functions we bound to the onChange prop. We defined those in the expense form before we returned the JSX code as well. Now we're doing the same here, one level above that in the new expense component for our own custom expense form component. So here I'll add a const save expense data handler. And important, as a parameter here, I will expect the entered expense data. The name of the parameter is up to you. It's your function. But now I make it clear that this function expects to get this parameter. And then here we can add our expense data, another object, copy in the entered expense data, which I expect to be that object which we generate here in the submit handler, so this object. I pull out all the key value pairs and add them to this new object, and then I add in a new key, the ID key, and simply set that to math random toString to convert it to a string. It's not a perfect unique ID. Theoretically, we could generate the same value twice, but it's good enough for this demo. And then we can see what we do with that thereafter. For the moment, I'll just log this enriched expense data. Now it's a pointer at this function, which I want to pass as a value to onSaveExpenseData. So that this onSaveExpenseData prop in my custom component receives this function as a value. Again, I don't execute it here. We don't add parentheses. I just point at the function so that the function itself, a pointer at it, is passed to expense form. Now that's the first step. The second step now is to use this function inside of our custom component. That's a step we didn't have to do for the inputs, because these are built-in components basically. But there also, we pass a function to onChange, and internally React then will add a listener and call this function which we pass in whenever that event occurs, that change event. Now, since we're doing this on our own custom component, we also have to call the passed in function manually. And that's what I'll do next. So inside of expense form, we now can expect this onSave expense data prop because I am setting it when I use the expense form component. Hence, inside of expense form, we can extract the value passed for this prop, i.e. this function. So inside of expense form, I of course now expect to get some props because we're setting a prop now. And now inside of the submit handler, instead of logging my expense data, I will access props on save expense data and execute it here. And that's now important. Now I execute it. I can execute it because the value which we get on this on save expense data key will be a function. We are passing in a function here after all. So it's this function defined in the new expense component, which we will now execute in a different component, inside of expense form to be precise. And we can execute the function, even though it's not defined inside of expense form, because we are passing a pointer at it through the onSave expense data prop. And this is a super important pattern which you will use a lot in React. This is how you can communicate between components and how you can communicate up. How you can make sure that a child component, the expense form component here, for example, can communicate up to the parent component, the new expense component in this case. We can call a function in the new expense component, and we can pass data as a parameter. So here, when we call onSave expense data in the expense form, I can pass the expense data which I generate here as an argument. And that's the value which we'll receive as a parameter here in new expense. I hope this flow is clear. The trick really is that we pass around a pointer at a function. Now if we go back and I reload, if I again enter something here and pick a date, if I click add expense, you see this is being logged to the console and it's being logged from the new expense file line 12. So it's this log here. And we can tell that it's from there because we also have an ID field there which has this random number which is generated and converted to a string. And that's how we can communicate up. And this is a super important pattern. Now, of course, we can continue in this chain now. And we can communicate up from inside new expense to app, because it's this app component which needs the new expense in the end to add it to this expenses array. So therefore, again, in app.js, we can add a function which we define before we return JSX code, and we can simply name this add expense handler. And we expect to get our expense here as a parameter, and then we do something with it. And for the moment, I'll just console log in app.js and console log the expense, because we haven't quite yet learned how we can render lists of data dynamically. And therefore, for the moment, I will not update the expenses array. That is something we'll do and learn about in the next course section though. For the moment, I just want to confirm that the data arrived. So here's the function. Now again, using the same pattern as before, we can pass a pointer at this function to new expense, so that inside of new expense, we can call this function and pass that expense data up to the app component. So we could name this prop here on add expense. Again, the name is up to you. It's your component. But again, I will follow this convention starting with on to make it clear that it's a function pointer, which is passed as an argument. And then I pass a pointer at add expense handler to the on expense prop on new expense. And therefore, inside of new expense, we can now call that. We can accept the props argument here as well, this parameter. And in save expense data handler, which itself is called when something happens in the expense form, we can of course now also call props on add expense. And of course here we want to use the name which we chose here in the app component. We're calling the function passed as a value for that on add expense prop. I'm calling this here, and I will forward my enriched expense data here. And if we now save everything, again, if I reload and I add a book here for $12.99, if I click add expense, this is being logged from inside the app component, as we can clearly tell. And I'm actually logging the expenses as I see. I wanted to log the expense instead, so let me fix this. Let me give this another try. A book, $12.99, pick a date. Yeah, so now we're logging the single expense. Again, we'll use that expense and change the array and output the array dynamically too. We'll do that in the next course section. But for the moment, I wanted to focus on that state and event handling thing. And being able to pass data up is a crucial part of that. And here's how it works. In the last lecture, we learned about a very important concept of moving data from a child to a parent component by utilizing props to receive a function from the parent component, which we call in the child component. And this is closely related to another key concept which we also already used without even knowing. And that's a concept called lifting state up. Now, what is that about? Consider this basic component tree, which is roughly what we have in this demo application, where we have an app component, which in turn renders an expenses and a new expense component. Now, in this case, the new expense component is a component which generates some data, some state. In our example application, we are fetching some user input here. Now, it is quite common that you do generate or fetch data in a component, but that you might not need that data in that component. Instead, we need it in another component, in the expenses component. That's where this generated data is needed in the end. Slightly transformed, packed into an object, but it is the data we fetch in new expense. So naturally, we would like to hand that data over. But that doesn't work like this because we have no direct connection between two sibling components. Instead, as you learned by now, we can only communicate from parent to child and from child to parent. That's why in such cases, like we have it here, we utilize the closest component, the closest parent component, which has direct or indirect access to both involved components. In this case, the app component. The app component in our application has access to both the new expense and the expenses component because it renders both components in its returned JSX code. That's why we want to utilize that, because we can now store our state in that closest involved component, so in that parent component which has access to both involved components, by lifting our state up. So by passing our generated state data from the new expense to the app component. And that's what we're already doing in this demo application. We're doing this by utilizing props, by calling the function we receive on the onAddExpense prop. That alone is not lifting the state up That's just calling a function we receive through props. But then we do something important. We actually do pass data to that function which we call here. We pass the expense data to the function we receive on the onAddExpense prop. So we're passing data to that function, and by doing that, we're lifting that data, that state, up. We're not keeping it in the new expense component. We're not keeping expense data there. Instead, we are lifting it up to the app component so that in there we can use it. Like an add expense handler, where at the moment we are logging it to the console. Now we're not yet managing that data as state here. Instead, we're just logging it to a console. But in the next course section, we are going to manage this whole array here as state, and we are going to add the expense to that array. And we are already passing down that array to the expenses component. Because that's the other part of this lifting the state up concept. We are lifting the state up, we are passing data up to some parent component because we either need that data directly in the app component, or, as it's the case in our demo application, and as it is quite common, because we then want to pass that data down to another component via props. That's what we did in the last course lecture. And that is an important concept. You will hear the term lifting the state up quite a bit when you're working with React, also later in the course. And whenever you hear that, it is about moving data from a child component to some parent component to either use it there or to then pass it down to some other child component. And as a side note, this does not just work if you have the app component which interacts with two direct child components. Instead, in this example already, the new expense component is actually not the component which generates the data which we're passing up. Instead, it's the expense form component which generates that data. It's that component which works with state and which fetches user input and stores user input. And that component then passes up that fetched data to the new expense component. So here we are already lifting state up. And then we're lifting it up even further to the app component, since it's the app component which is then the first component in line, which does not just have access to the new expense and expense form component, but also to the expenses component. And since the expenses component is the component where we need the data in the end, it is the app component where we want to lift our state up to. Now, as you will see throughout this course, it's not always that root app component to which you want to lift your state up. Instead, the goal is to lift it up just as high as necessary in your component tree until you have a component which has both access to the components that generate data as well as the components that need data. That might be the app component, but that could also be another component. Again, you are going to see this quite frequently throughout this course. Now that's it for this section. In the last section, we again implemented two-way binding as part of the assignment. Actually, it was a bonus section of the assignment, I would say. But again, we added two-way binding, and we did something which has an official term in React, which I don't want to hide from you. We created a controlled component. And it's not the first time we did that. Basically, whenever you use two-way binding, you are controlling a component. But here we're controlling our own custom component. Now, what does this mean? It means that a value which is used in the component, like the value selected in the dropdown, is passed on to a parent component through props and is received from the parent component. Both the currently set value as well as the function which in the end handles the selected value is not part of expenses filter. Expenses filter is really just a component that presents the UI, that presents the dropdown, and then attaches a couple of listeners or props. But the real logic resides in the parent component. And that turns expenses filter into something which is called a controlled component. Now, technically, there is no difference. Expenses filter is still a regular component as you learned it. It's just a special term that when you see it, basically means what I just explained, that both the value as well as changes to the value are not handled in the component itself, but in a parent component. This component controls the expenses filter component. And that's just a term which you should be aware of. Another term or another concept you should be aware of, because you might hear it from time to time, is about presentational versus stateful components, or stateless versus stateful components, or dumb versus smart components. There are a lot of terms for that. But what do they mean? It simply means that in basically all React apps which you're building, you will have a couple of components that manage some state, like this expenses component, which manages this filter state, or the expense form component, which manages the input state. And then you will have other components which don't manage any state, like expense item, if we remove the button, which we should do because it was just there for demo purposes. If we remove it, we can also remove the use state call, and we should remove it. We can also remove that and that. And if we do all of that, and we set this here back to props title, then this is a stateless component, as it should be. This component is a stateless component, also called presentational or dumb component, because it doesn't have any internal state. It's just there to output some data. And in most React applications, you will have more presentational and dumb components than smart or stateful components. So even though dumb might sound negative and it might sound like stateful components are better, that's not the case. These are really just terms, and typically you end up with less stateful components than with stateless components. Because you want to split up your application into small reusable pieces, and most pieces, most components, indeed will only focus on outputting something, on having some JSX code, maybe some transformation logic like this here, and maybe some CSS code. But it's only a couple of components which typically do manage state. And then this state is spread out and distributed through props in the end. Like here in the expenses component, where we manage the filter state, and then we pass the filtered year, so this state value, through props back to expenses filter. This is a standard pattern which you'll see a lot, that you manage state in a couple of components, and then you might pass that around to other components. And that's basically it for this module. What you learned here, again, was super important. So make sure it's clear to you, make sure you understand what state is and how you can handle events and how you can pass data from a child to a parent component. And with all of that, combined with the course section before, where we covered components in general, we're now prepared to dive into the next course section and basically conclude the hardcore of React basics. But the next section again will be super important because it will be about lists and conditional content.